All right, so for the first ones, this is going to be like your quiz. Like I've said a bunch of times, you're going to have one proof where you have to just fill in the blank for two of the reasons, okay? So they're going to give you something similar to this proof, where they give you some givens, and then they give you some steps, and then you fill in the reasons for the steps, okay? So for the first one, if we're asked to complete the two-column proof, it says angle B is congruent to angle D, okay? So it looks like this. And this is B, and this is D. So it says those two are congruent, and then this is CE. Just excuse the fact that it's kind of not straight. Okay, so we are given that, and then we're also given that CE bisects angle BEC. Okay? So CE, that, you know what that's supposed to say? Angle BED. That's supposed to say angle BED. Okay, hopefully you figured that out. Okay, so it's saying that CE is bisecting this angle, this angle. Okay, so what that does, well, what does that do? If this bisects this angle, what does that do, Lindsay?
Makes the two angles each other.
Yeah, it makes these equal to each other. Okay, so that's part of it. Now it says angle BEC. I messed this up, didn't I? Oh no, I didn't. Okay. So angle BEC on that same note, angle BEC it says is congruent to angle BEC. Why would be the reason for that? Okay, did you hear that? Okay, definition of an angle bisector. So that would be the reason for number 2. Definition of an angle bisector. Because an angle bisector splits an angle into two equal angles. Okay? So that's number 2's reason. Then it says CE is congruent to itself. Okay, we all know that's because of the reflection property. Now, how can we take what we have here and say that the two triangles are equal, this one and this one? Kylie? Okay, look at what we have on each triangle. You have 4 options. You have this, you have this, this, and this. Okay, and it has to go in order of what it's listed as. Okay, so if we try them out, okay, and you can do this too. Do we have 2 sides even? No, so that one's not in the running. Do we have 3 sides? Obviously not. Okay, we don't have 2. So it would have to be these 2. Now, how do I know whether it's angle, angle, side, or angle, side, angle? Because I think this is where we're getting tricked up. Because you're looking at one triangle at a time. Don't look at both together. So one triangle has angle, angle, side. Okay? It does not have angle, then a side, then an angle. What that would be this. Angle, side, angle. Okay? It has to be in the middle, not after the 2 angles. So it has to be angle, angle, side. Yeah.
What if it, like, can it be B and then we go through C?
What?
Can it be B and then you go through C?
B and then you go through C to E.
Yeah, like angle, side, angle. C is like the best.
Because there's a side and an angle in between it. You can't skip things and just go. That's a good question. She said, what could it be like this? Angle, side, angle? No, because you have a side in between that and another angle in between that. You can't have anything in between. Okay, that's a good question though. Okay, so it has to be angle, angle, side is what that is. Okay? For numbers 3 and 4, again, this is going to be a very similar figure that you see on your quiz, okay, where it looks like this. And again, excuse my drawing. we need to know that these three sides are equal on that triangle. And then it says that's angle 3. And then it says this is a right triangle where the two sides are equal. And that's angle 4. So how would we find angles 3 and 4? And it doesn't really matter which order we do these, but let's say, or what do we start with? Kylie, what did you start with?
If you know all the sides are equal on that triangle, then all the angles are equal too. So that's
Okay,
60.
so angle 3, if we look at this triangle, all the sides are equal. So if all the sides are equal, all the angles are equal. All the angles are equal. We know that they add up to 180, so we just have to divide by 3. So that makes angle 3 equal to 60. Okay? Now, how would we find angle 4?
Since on that triangle has two equal sides and it's isosceles, so the two angles next to it must be.
Okay, so isosceles triangle, this one with the angle 4, means the two opposite angles here to the sides have to be equal. So that makes this equal to this. Now if that's equal to that, and we know this is 90, we just have to do 90 plus, we could do 2x equals 180. I think you could probably do it in your head, but this would be how you would figure it out. So you just split 180 minus 90. Oops, 180 minus 90 is 90. By 2. So you get x, or one of the angles, to be 45. Okay, so angle 4 is going to be 45. And you have a very similar question to that on your quiz. Now, kind of on that same idea, if it says the base angle of an isosceles triangle is 40. If I just draw an isosceles triangle, okay, like that, and this is the basic isosceles triangle, it's saying the base angle, so one of the base angles here. So, doesn't matter which one because it's isosceles and both of them are equal. So what is the measure of the vertex angle? What does that mean? Well, these are the base angles. This would be the vertex angle. So what it's saying is, what is the measure of that angle when you know that one of the base angles is 40? What would you do? Kylie?
It means both of them are 40.
Yeah, these are both 40. And then,
Subtract 80 from 180.
yeah, and then we know that all the triangles have 180 as all their angles. So we just subtract 180 minus 80. And that'll give us our vertex angle is 100. Check the video here. Okay, that's gonna look weird on the YouTube. I just checked. All right. Questions on that one? That one there?
Oh, are we filming video?
You're the privileged class.
Wait, what?
Algebras was fighting over which one was going to film the video. Okay. All right. Next one, the next page, you flip it over. Okay. This is identify the type of congruence transformation shown as a reflection, translation, or rotation. Okay. So look at the picture there. You have just a picture to look at. For up here, it looks like this. Okay? What type of transformation would that have to be? Think about which one is which, what they mean, yes?
It could be a reflection or a translation.
Okay, so reflection is when they take the shape and they flip it across either the y-axis or the x-axis. Okay, so if I were to flip this shape and bring it over to here, that would actually work. So it could be a reflection. Now, a rotation would mean that I would be moving it circular, so that really wouldn't work for a rotation. But then a translation, as he said, it could also be a translation because it's a slide. Okay, because if we slide the figure over without moving it, just slide it to the left or the right or up or down, it's not moving, it's just, I mean, it's not changing the figure, it's just moving it here. So it could also be a translation, okay? So it actually can be either one, yeah, or both, is what they. So if it's more than one on the quiz, you wanna list all that's possible, okay? All right, and then 7 and 8, we were doing, where we were positioning the triangles, okay? Let's see,
Wait, I thought you said there weren't gonna be any of these other quizzes.
these are gonna be, these are gonna be like the ones on your quiz. There's not gonna be any coordinate proofs, which, let me just say, coordinate proofs, like the last one, that's the only one you're gonna see. Okay, you're not gonna do a real coordinate proof, so that's not gonna be on the quiz, but these are. Okay, so we have right triangle ABC is what it's saying to describe here, with hypotenuse AB. CB is okay. Let's do one thing at a time. So we have our coordinate plane. Now, what does it usually say that we want to try and that we want to try and do here with the triangles? What does it usually say we need to try and do when we're trying to position them? What are some of the things that, remember it had that box where it had 4 different things that you want to think about? What would be something that we need to think about, putting the triangle on here? Where does it usually need to try and be? In the first quadrant if possible. Okay, sometimes in both quadrants here, the first and the second. But if possible, they try to say, put it in the first quadrant. What else do they try and say? Try and keep at least one side on the axis, okay? And then there's another thing too. What else do you want to try and do? One of the points on the origin, okay? Okay, so let's see if we can try and do this. If it's a right triangle, then I think that we can try and set up the sides to be on each axis like this. Okay, something like that, where you have the right triangle. Now you have these 3 vertexes or vertices, okay? Now we just need to label it appropriately. So if it says hypotenuse AB, which one is the hypotenuse? Cynthia?
The angle line.
Okay, the one across from the 90-degree angle or the diagonal line here. So it wants that to be AB. So that makes this have to be C. So that told us where to put the letters. Then it says CB is half AC. All right, well here's CB. Now it doesn't look like it is based on my drawing, but it says CB is half AC. Okay, so I'm just going to put this here for right now. Now it says AC is A units long. So this is A. Now, how would we label the points? That's what we need to label. So what is C? That's easy, right? 0, 0. Okay. Now think about A. What would that be? 0, not 0B. 0A, just because we want to use the letter that they used. So that is 0A. Okay, 0, 0, 0, A. Oh no, is it A 0? No, 0A. That's right. Okay, 0A. And then how would we get B? If it's half of